So the second part of the assignment is to decide whether this is a valid model or not. There are various model diagnostics that we can conduct or tests that we can conduct to make this determination. One that is not necessarily a diagnostic test, but it's almost a task that we can conduct to visually inspect the data and make a decision about what it is that we have here, is simply a correlation analysis. And we can click on summaries and click on the correlation matrix and ask for all these variables to be included in the correlation matrix. And we know that these are all continuous variables, so Pearson's product moment is the type of correlation that we're going to run. Let's click on OK, and let's look at this correlation matrix. Obviously, age and age is going to be a perfect correlation. It's the same variable against itself. Beauty and age, a small correlation. Salary and age, 0.39. Okay, as we start looking at a moderate correlation. Years and age, 0.95. One is a perfect correlation. 0.95 is an extremely high correlation. We might start to decide that we have an issue of collinearity here, where two explanatory variables are highly related to each other, not allowing our statistical analyses of regression to decide or understand the data correctly as independent, separate variables. And so what we need to do is we actually need to conduct our test. Let's go ahead and click on R Commander again, and let's conduct our model diagnostics. We have numerical diagnostics here. Two that the book recommends and that are commonly conducted are VIFs, or variance inflation factors. A variance inflation factor looks at the influence of one variable on another variable and may help us determine whether there's collinearity or not. Usually a VIF of less than 10 is within the acceptable range, and a VIF of greater than 10 is outside of the acceptable range according to field. If you look at age and years, we might start to again confirm now, not simply decide or guess, but we start to confirm that there is an issue of multicollinearity here. And that would be a problem. And we may have to actually decide that we don't have a model that is valid. Let's look at another numerical diagnostic, the Durbin-Watson test for autocorrelation. And this is also considered a test of independence of errors. And if you have errors that are dependent on each other, you may confirm that you have a problem of autocorrelation. And if that is the case, then you may have an issue with your data and ultimately with a model. Let's click on OK. Notice, by the way, when I'm looking at this numerical diagnostic, I've selected the row to be equal, not equal to 0. You can have positive autocorrelation, negative autocorrelation. We simply want to say that we're looking for correlation that is not equal to 0. Click out of this right here and let's look at the values. The first thing that we look at is the Durbin-Watson statistic, which is 2.05. The field recommends that a Durbin-Watson statistic between 1 and 3 is within the acceptable range, suggesting that there's not necessarily autocorrelation in this specific model. However, this is one of several tests. Let's look at something else. go ahead and go back to R Commander, click on Models, and let's add observation statistics to the data. You can look at fit values, residuals, studentized residuals we're going to click out of, values we're going to click out of. Let's keep Cook's distance, and we can keep observation indices in. We may not be discussing them. I'm going to click out of it actually. So let's go ahead and click on OK. And notice what we get here is simply evidence that this has actually been run. These have been populated as new variables. If you click on Supermodel, we can see that Cook distance is here, and we can see the residuals, and we can see fitted, a variable with the name of fitted values. If I go back to R Commander and I click on View Data Set, I can actually see these variables as well. We said that residuals was important to making a decision whether data was appropriate and was free of errors and issues, which would then confirm the validity of our model. Our residuals here, if we look at this column, is expressed again this nomenclature, not very helpful to us. We could standardize these residuals and we could look at them again. I know that we've done this in class previously and we found that we had an issue. I think I found a solution to that issue, at least on where we could look at the standardized residuals. So if we click on statistics and actually on data, manage variables in the active data set, where we find standardized variables, we can click on residuals so we can standardize our residuals and click on OK. Now what this is going to do is can create a new column in our data set, and if we click on R Commander again and we say View Data Set, we will now find a variable that's called standardized residuals, or Z-score residual, or Z residual. So we have Z residuals for Supermodel Model 1. And notice that again, these are in this nomenclature. We don't care about this. I mean, this is really hard to interpret. We're usually looking for standardized scores, anything with a mean of 0 and 1 and 2 and potentially even 3 standard deviations away from the mean, making the decision that anything above a positive or negative 2 or absolute value of 2 would be considered an outlier. But we can't see that here, so let's click out of this and let's click on Edit Data Set. And let's look at the data in this window. If we look at the residuals, actually these are expressed in the fashion that we're interested in. Look at case number 2, greater than 2. Look at case number 5, it's greater than 2. And we could do the same for all of the data and determine who is above or below positive, negative 2 standard deviations from the mean. And here we have another case. This is case 91 and so forth. And we can actually see this in a different way. Let's discard edits. We're not editing anything. By creating a box plot of the residuals. And click OK here. And you will see that the cases that emerged as outliers in our standardized residuals are also pointed out here: 2, 24, 41, 127, 191, and so forth.